We'll start in about a minute. We'll do more from Chapter 7, Section 7.2, and the first part of 7.4 on solving equations with rational expressions. We have Test 2 on Thursday, which will be over what we covered in Chapters 4, 5, and 6. Tomorrow and Wednesday, we will have a test review during class. So Chapter 7, Section 2, we review adding and subtracting fractions or rational expressions. So just like fractions, rational expressions must have common denominators before they can be added and subtracted. So we'll look at some examples where we add and subtract fractions as well as rational expressions. Okay, on this one, 17/30 plus 11/45, we have to have a common denominator. So the least common multiple of the two denominators, or the least common denominator, we can find that using prime factorizations. So one denominator is 30, and we'll write down the prime factorization of that. And then the other denominator is 45, and we'll write down the prime factorization for 45. The prime factorization of 30, 2 times 15, and 15 is 3 times 5. So each one of those factors is a prime number, and when you multiply them, 2 times 3 times 5, you get 30. For 45, well, 3 goes into 45 15 times, and so 3 times 3 times 5 is the prime factorization of 45. And the least common multiple of 30 and 45 must have the prime factors of both of those numbers. Since 2 is a prime factor of 30, 2 must also be a prime factor of the least common multiple. 30 has a prime factor of 3, and 45 has a prime factor of 3 twice. So in the least common multiple, 3 times 3 has to be in the prime factorization. And then each of the numbers 30 and 45 have 5 as a prime factor once. So in the least common multiple, 5 appears only once. Okay, so remember what a multiple is. This number, 2 times 3 times 3 times 5, must be a multiple of 30 and 45. When you multiply these out, you get 90. 2 times 3 is 6. 6 times 3 is 18. 18 times 5 is 90. And you can see that 90 is a multiple of 30 because 3 times 30 is 90. 90 is also a multiple of 45 because 2 times 45 is 90. So the least common denominator is 90. So we change the fractions to their equivalent fractions with denominators of 90. Okay, so to convert 17 over 30 to a fraction with a denominator of 90, we have to multiply the numerator by 3, because 3 times 30 is 90. So 3 times 17 is 51. And similarly for the other fraction, the fraction 11/45 is equivalent to 22 over 90. And now that the denominators are the same, we can add the fractions. The denominator of the sum will still be 90, and the numerator will be 73. 51 plus 22 is 73. So hopefully that's review, adding fractions. We use the same idea if the fractions have variables. So on this one, 3x squared y is one denominator. The other denominator is 2xy squared. So the least common denominator, which is the least common multiple of the denominator, has to be a multiple of each of those two denominators. So let's look at the coefficients first, 3 and 2. So a multiple of 3 and 2 is 6. Then when we compare the variable parts, x to the second in one denominator and x in the other, x to the second is a multiple of both x to the second and x. And then when we compare y and y squared is a multiple of both y and y squared. So the least common multiple of the denominator is 6x squared y squared. Okay, so we have to make proper adjustments. We'll write down the sum of two fractions with each with the denominator of 6x squared y squared. This numerator is 5, and so we have to identify what we need to multiply by 5 that corresponds with this denominator, 6x squared y squared. So we need a factor of 2, and we also need a factor of y. Because the difference in this denominator, 3x squared y, and this denominator, 6x squared y, is 2 times y. And similarly for the other rational expression, we're starting out with 7. And when we compare this numerical factor 2 with this one 6, we see that we need a factor of 3. This denominator has x, and this one has x to the second, so we have to have a factor of x. And both of them have a factor of y squared, so we don't need any more y factors. Okay, then we'll simplify a little bit. In the numerator, 5 times 2 times y is 10y over 6x squared y squared. And 7 times 3 times x is 21x over 6x squared y squared. And now that the denominators are the same, the sum will also have the denominator 6x squared y squared, and the numerator is 10y plus 21x. Okay, when subtracting, we still have to have common denominators. Okay, the two denominators are 5xy for one and 2x for the other. So the least common denominator must have a factor of 5 and a factor of 2, so 5 times 2. Each of them has one factor of x, so the least common denominator has one factor of x. This denominator has a factor of y, so the least common multiple must also have a factor of y. So we simplify this a little bit, we get 10 times xy for the least common denominator. Okay, so rewrite the difference with the common denominator 10 times xy. The fraction on the left, the difference between 5xy and 10xy is a factor of 2, so we have to multiply 4u times 2. And then for the next fraction, the difference between the denominator 2x and the denominator 10xy is 5y. So we multiply the numerator 3 times v times 5y. Then we'll simplify a little bit. 4 times u times 2 is 8u. And 3 times v times 5 times y is 15v times y. So the simplified answer, the denominator is 10xy, and the numerator is 8u minus 15by. Okay, the next one, 2 over x minus 2 plus 3 over x plus 5. The least common multiple of the denominators. Well, these are binomial factors, so the least common denominator is the binomial x minus 2 times the binomial x plus 5. Okay, so we'll write those with the common denominator, x minus 2 times x plus 5. So in the original fraction, the numerator has a factor of 2. But in this one, we have to also include a factor of x plus 5. For the other fraction, we started out with a denominator of x plus 5. The numerator has a factor of 3, and we also have to include a factor of x minus 2. Okay, so we can write this with the common denominator, x minus 2 times x plus 5. And then we have some simplifying to do in the numerator. We'll go ahead and multiply 2 times the quantity x plus 5 to get 2x plus 10. And then we're adding 3 times the quantity x minus 2, which is 3x minus 6. we can simplify further. So if you're taking a written quiz or a written test, you can leave the denominator in factored form if you want, x minus 2 times x plus 5. But then simplify the numerator by combining like terms. 2x plus 3x is 5x, and plus 10 minus 6 is plus 4. So that is our simplified result. And the next one, we have a difference of two rational expressions. The denominators are binomial factors. The least common denominator is just y plus 7 times y minus 3. Yeah, another way to go about this is if we multiply the fraction 5 over y plus 7 times 1 in the form y minus 3 over y minus 3. And then we're subtracting the other fraction multiplied by 1. This time we multiply by y plus 7 over y plus 7. And then do the arithmetic. So you always have to be careful, especially with subtractions and negatives. Okay, the common denominator is y minus 3 times y plus 7. And then on the left, in the numerator, 5 times the quantity y minus 3 is 5y minus 15. And here you have to make sure you subtract the product of 4 times y plus 7. We have to subtract 4 times y. And we also must subtract 4 times 7, so minus 28. And we're just one step away from the simplified answer. The denominator is y minus 3 times y plus 7. And in the numerator, 5y minus 4y is y. Minus 15 minus 28 is minus 43. So online, I have 10 people who signed in, but only 8 people who were watching. So evidently, a couple of people signed in and then checked out. So I might have you re-sign in a few minutes. Hey, this one's a little more complicated. Uh, 2x over x squared plus 2x minus 8 plus 4 over x squared plus 3x minus 10. Well, what we need to do is factor the denominators so that we can find the least common denominator. So x squared plus 2x minus 8, it doesn't take too long to find that the factors are x plus 4 and x minus 2. And then the other one, the x squared plus 3x minus 10, that is x plus 5 times x minus 2. Okay, when we compare the denominators, well, the least common multiple of the denominators has to account for all of the binomial factors. So x plus 4 and x minus 2 must be in the least common denominator, x plus 4 times x minus 2. And in the other denominator, we have the binomial factors x plus 5 and x minus 2. So the least common multiple has to have the factor x plus 5. The factor x minus 2 is already accounted for because it's a factor in both denominators. So if we write down an additional factor of x minus 2, you can still make it work, but it's more work than you want to do. If you include an additional x minus 2 factor, it won't be the least common denominator. It'll be a common denominator, but not the least. And arithmetic is easier if you just use the least common multiple. Okay, so this fraction on the left, this denominator is missing x plus 5. So if we multiply 2x over x plus 4 times x minus 2, if we multiply by 1 in the form x plus 5 over x plus 5, we'll have a fraction or a rational expression with the common denominator, the least common denominator. And then we'll do the same sort of thing with the other one, the other fraction, 4 over x plus 5 times x minus 2. So this denominator is missing the x plus 4. So we multiply by 1 in the form x plus 4 over x plus 4. Okay, so the common denominator, x plus 5 times x minus 2 times x plus 4. So in this part of the numerator, we multiply 2x times the binomial x plus 5. We get 2x to the second plus 10x. And then we're adding 4 times the binomial x plus 4, which is plus 4x plus 16. And there's one more step. We can still simplify the numerator by combining like terms. So in the numerator, we have 2x squared, and then plus 10x plus 4x is plus 14x, and then plus 16. Here, the next one is the same sort of thing. This time we're subtracting. So we want to factor the denominators. Y squared minus 3y minus 4. One factor is y minus 4. The other one is y plus 1. In the second denominator, y squared minus 5y plus 4. One factor is y minus 4, and the other factor is y minus 1. So the least common denominator has to have all of the factors that are in both denominators. So the least common denominator has factors y minus 4 times y plus 1 times y minus 1. Okay, then we multiply each of those original fractions by 1 in a particular form. So 3 over y minus 4 times y plus 1. So what form should 1 take when I multiply 3 over y minus 4 times y plus 1 by 1? Yeah, I got an answer online. So y minus 1 divided by y minus 1. So now we have the least common denominator. And then we multiply the other fraction by 1. So the form that 1 takes for this one is y plus 1 over y plus 1. So just to elaborate a little bit on this, we know that if we multiply something by 1, we're not changing the value. And a number divided by itself is 1, as long as you're not dividing by 0. Okay, now that we have the common denominator, we'll simplify the numerator. So up here we have 3 times the binomial y minus 1. That's 3y minus 3. And here we have subtractions, so watch out for subtraction. We have to subtract 2 times y, and we also have to subtract 2 times 1, so minus 2. Okay, then simplify. In the numerator, 3y minus 2y is y, and minus 3 minus 2 is minus 5. Okay, the next one is easier than it might look. So on this one, note that this denominator, 2 minus y, is the negative of y minus 2, and vice versa. All right, if you take the negative of y minus 2, you get negative y plus 2, but that can be written as 2 minus y. So what we can do well, we have a couple of options, but one option is to multiply 7 over 2 minus y multiplied by 1 in the form negative 1 divided by negative 1. This is just one way to do it. So negative 1 divided by negative 1 is just 1. We're just multiplying by 1. So if I simplify a little bit, 7 times negative 1 is negative 7, and 2 minus y times negative 1 is just y minus 2. And now the denominators are the same. So we can write y plus -7 or y minus 7. So that's all there is to that one. You could still make it work if you wrote down that the common denominator is y minus 2 times 2 minus y. But it's more work if you do it that way. And there's a chance that if you do it that way, you might not write the completely simplified answer in the end. Okay, the next one, 3x over 2x minus 3 minus 2x plus 1 over 3 minus 2x. Okay, so this is similar to the one that we just did. The denominators are negatives of each other. 2x minus 3 is the negative of the denominator 3 minus 2x. So if you recognize that, then you can do what we did in the last one. We can multiply this by 1 in the form -1 times -1 divided by -1. And then be careful with the subtractions and the negatives. So in this denominator, 3 minus 2x times -1 is -3 plus 2x, but that's equivalent to 2x minus 3. And then when we multiply the binomial 2x plus 1 times -1, we get -2x minus 1. Okay, so with the common denominator 2x minus 3, so be careful. Up here we have 3x minus -2x. And 3x minus -2x is this equivalent to 3x plus 2x. And we're also subtracting -1. When you subtract -1, that's equivalent to adding 1. And then we combine the like terms in the numerator. 3x plus 2x is 5x. So our numerator is 5x plus 1, and our denominator is 2x minus 3. Okay, the next one, 3x over x squared plus x minus 12 plus x over x squared minus 2x minus 3. So let's factor the denominators. X squared plus x minus 12. One factor is x plus 4. The other one is x minus 3. And then in the other rational expression, x squared minus 2x minus 3, one factor is x minus 3, the other one is x plus 1. Okay, so the least common denominator, the least common multiple of the denominators, has to be a multiple of both denominators. So the least common denominator is x plus 4 times x minus 3 times x plus 1. Okay, so multiply this fraction by 1 in the form x plus 1 over x plus 1. x plus 1 over x plus 1. And then multiply the other fraction by 1 in the form x plus 4 over x plus 4. Okay, then we can add the fractions because they now have common denominators. Okay, over here on the left, 3x times the binomial x plus 1 is 3x squared plus 3x. And then we're adding x times the binomial x plus 4 for plus x squared plus 4x. Okay, just one more step. When we combine the terms by adding in the numerator, 3x squared plus x squared, 4x squared, and then plus 3x plus 4x is plus 7x. And then the denominator, x minus 3 times x plus 1 times x plus 4. Okay, the one on the bottom, let's factor the denominators. Okay, so 2x squared minus 3x minus 2. So let's see. So what do we need? We need a 2x plus 1 and a x minus 2. For the other denominator, we need 2x plus 1 and x minus 4. Yeah, so the least common denominator is 2x plus 1 times x minus 2 times x minus 4. Okay, I'm going to probably run out of space, but we're going to multiply the fraction on the left by 1 in the form x minus 4 over x minus 4. So I'll just write 5 times x minus 4 over the common denominator. And we're subtracting, so we're going to subtract 4 times quantity x minus 2 over the common denominator. So we can write the final result. So we'll just do some of this in our head. We'll have the common denominator. So over here on the left, 5 times x minus 4 is 5x minus 20. And we're subtracting 4x minus 8. So 5x minus 4x is just x. And negative 20 minus negative 8 is negative 20 plus 8, or negative 12. So we have x minus 12.
Good question. In the numerator, on the original problem, it's 5x. It's not just 5.
Oh, yeah. You're right. 5x is what we started with. 5x. Okay. So that means we have 5x times x, which is 5x squared, minus 20x minus 4x is minus 24x. And then minus negative 8 is plus 8. Okay. In the next few minutes, we'll cover the first part of Chapter 7, Section 4. On Friday, we'll do the rest of Chapter 7, Section 4. Okay, solve equations with rational expressions. So you might agree with this statement. This is just an opinion. There's nowhere written in the cosmos that this is an absolute truth. But in my opinion, solving equations with fractions or without fractions is easier than solving equations with fractions. You might agree or you might not. But to illustrate, let's solve each of the two equations below. The equation on the left doesn't have fractions. Solve this. 2x minus 3 equals x plus 4. And we can solve it in 2 steps. If I add 3 to both sides to start with, I get 2x equals x plus 7. And then I can subtract x from both sides and get x equals 7. And we can visually check to see if 7 is the solution. Replace x with 7. 2 times 7 is 14. 14 minus 3 is 11 on the left-hand side. And on the right-hand side, 7 plus 4 is 11. So that was simple enough. The equation on the right has fractions, so it's not too bad. We can just add 5/4 to both sides. So we get 5/12 x equals 5/3 plus 5/4. And then we can add these two fractions if we have a common denominator. The common denominator is 3 times 4, or 12. So we'll write this as 5/12 x equals 5/3 times 4/4. We're just multiplying by 1. And then add that to 5/4 times 3/3. We're just multiplying by 1. So we get 5/12 x equals 20/12 plus 15/12. So up here, I'll continue 5/12 x equals 35/12. And what do we do now if we have 5/12 x equals 35/12? We can multiply both sides by the reciprocal of 5/12. So when we multiply 5/12 times x by 12/5x, we're just going to get 1x. And then on the right-hand side, multiply 12/5 times 35/12. And then 12 divided by 12 is 1. 5 goes into 5 once and into 35 7 times. So we get x equals 7. So this equation on the left, so when I made up this example, I started out with this equation with no fractions. And then all I did was multiply this equation on both sides by fractions until I got this. So this equation is just a manipulation of this one. But I don't know, it seems pretty clear that solving the equation without fractions is easier than without fractions. Wait, the other way around. Solving without fractions is easier than with fractions. Okay, so I'll explain a procedure that you can follow to solve equations with fractions or rational expressions. First, find the least common multiple of the denominators. And then you also want to identify any restricted values that you might have. If the denominators are just numbers, non-zero numbers, like this one doesn't have restricted values because the denominators are just numbers, non-zero numbers. Then after you find the least common multiple of the denominators, multiply every term on both sides of the equation by the least common denominator. This is sometimes referred to as clearing the denominators. Another way to describe it is if you multiply every term on both sides of an equation by the least common denominator, you will reduce every denominator to a factor of 1. Okay, then solve the resulting equation and check the results. And if the solutions from step 4 are not restricted values, then they are the solutions to the original equation. Okay, so I should have saved some space to apply that process to this equation up here with fractions, but I think we can do that here. If I rewrite 5/12 x minus 5/4 equals 5/3, what's the least common denominator? The denominators are 12, 4, and 3. So the least common multiple of 12, 4, and 3 is 12. Okay, then multiply every term on both sides by 12. So 12 over 1 times 5/12 x minus 12 over 1 times 5/4 equals 12 over 1 times 5/3. And then 12 over 1 times 5/12 x, the 12 divided by 12 equals 1, so we're left with 5x. And then 12 over 1 times 5/4, 4 goes into 4 once and into 12 3 times, so we're just left with minus 3 over 1 times 5 over 1, which is minus 15. And then on the right-hand side, 12 over 1 times 5/3, 3 goes into 3 once and into 12 4 times. And 4 over 1 times 5 over 1 is 20. So now we have a simple equation to solve. Add 15 to both sides, we get 5x equals 35. Then divide both sides by 5, we get x equals 7. Okay, we have about 2 minutes left. Let's at least get started on this one. Solve this equation. 1 over y plus 2/3 equals 1/5. The least common denominator is y times 3 times 5, or 15y. And then multiply every term on both sides by 15y. So we get 15y over 1 times 1 over y plus 15y over 1 times 2/3 equals 15y over 1 times 1/5. And 15y over 1 times 1 over y, the y's cancel, so we just get 15. And then 15y over 1 times 2 over 3, we get 10y when we simplify that. And on the right-hand side, 15y over 1 times 1 over 5, we get 3y. So this equation is simpler to solve. If we subtract 10y from both sides, we get 15 equals negative 7y. And then divide both sides by negative 7, we get y equals negative 15/7. Okay, we're out of time. So tomorrow and Wednesday, we will go over the test 2 review sheet. And then we'll have our test on Thursday. So that's all for today.